Ever feel like you're living in the future?
Hmm.
Self-driving cars, computers that can write poetry, it's
Hmm.
wild. And underpinning a lot of these mind-blowing advancements is something called a neural network. They're like the engine driving the AI revolution, and today we're diving deep into the algorithm that makes them tick. Backpropagation.
Right.
So whether you're brushing up for a tech presentation or just insatiably curious about how the world is changing, we're here to break it down. We're taking a deep dive into the research you sent us, everything from academic papers to real-world applications, to understand how this one algorithm, backpropagation, is everywhere these days. And to help us connect the dots, we have our resident expert.
Glad to be here. Neural networks are just endlessly fascinating to me.
Yeah.
The way they mimic the human brain to solve complex problems, it's truly remarkable.
Okay, so you've got me hooked. Let's unpack this. You shared a paper with a pretty straightforward title, Brief Introduction of Backpropagation, BP, Neural Network Algorithm and Its Improvement. Is that a good place to start?
Absolutely, it lays the groundwork. You can think of backpropagation, or BP for short, as the learning process of a neural network.
Okay.
Imagine a network of interconnected nodes, kind of like a giant web of information. Each connection in this web has a certain strength or weight that determines how much one node influences another.
So it's like a network of roads, and some roads are bigger highways that carry more traffic than others.
Exactly. Now imagine you want this network to learn something new, like recognizing different types of cars and images. BP is what allows the network to adjust those road sizes, those weights, based on its mistakes.
So it's constantly learning and improving by tweaking those connections.
Precisely. It compares its output, what it thinks it sees, to the correct answer. If it's wrong, it goes back and fine-tunes those connections, a little stronger here, a little weaker there, until it gets better at producing the right answer.
That's really cool. It's kind of like learning to ride a bike.
Uh-huh.
You keep adjusting your balance and steering until you get it right.
That's a great analogy. And speaking of recognizing things, one of the sources you were curious about was vehicle-style recognition based on image processing in neural network.
Yeah, that one caught my eye. It
Yeah.
sounds like something straight out of a sci-fi movie. Cars recognizing each other.
Right.
What's the story there?
Well, this research delves into using BP to teach a network to identify different styles of vehicles from images, which, as you can imagine, is incredibly complex.
Right, different angles, lighting conditions, not to mention all the different makes and models out there.
Exactly. And this is where those adjustable weights we talked about come into play. The network has to learn what features are important for distinguishing a sedan from an SUV, for example. And it does this by analyzing a massive amount of data images of cars from all sorts of angles and in various conditions.
So it's like training a computer to see the world the way humans do, but even better because it can process so much more information.
That's the idea. And to accomplish this, the researchers used a specific type of network architecture with input and hidden layers.
Yep.
Think of it as a multi-stage process.
Okay, walk me through it. What are these input and hidden layers? It sounds kind of mysterious.
Not at all. It's actually quite straightforward. The input layer is like the entry point where the raw image data goes in. All those pixels get fed into the network.
Right.
Then those hidden layers, they do the heavy lifting. They're like teams of specialists, each analyzing different aspects of the image, looking for patterns and features. One layer might specialize in edges, another in shapes, and so on. It's the combined knowledge of these layers that allows the network to recognize, say, the distinct silhouette of a sports car versus a pickup truck.
So it's like a whole assembly line of analysis happening within the network.
Precisely. Each layer builds upon the previous layer's understanding, gradually building a more sophisticated representation of the image until finally the network spits out a prediction. This is a sedan, or this is a convertible, and so on.
Amazing. It sounds like we're already on the road to self-driving cars with this kind of tech.
And speaking of taking action, let's shift gears from recognizing objects to something even more dynamic: robotics. You shared a fascinating paper on research on multi-robot path planning methods.
Oh, yes. Robots. That's where I thought things got really futuristic.
Right.
How does BP fit into making robots move and navigate?
Well, think about the challenges a robot faces. Navigating a cluttered room, avoiding obstacles, finding the most efficient path. It's a lot like learning to walk, but in a much more complex environment. And just like with image recognition, backpropagation could be used to train a robot's control system to navigate these challenges effectively.
So the robot is essentially learning from its mistakes, much like the neural network was adjusting its weights.
Exactly. Instead of adjusting connections between nodes, in this case, the algorithm tweaks the parameters that control the robot's movements, its speed, direction, how it reacts to obstacles. It tries something, sees how it works, adjusts, and tries again, becoming more adept at navigating its environment with each attempt.
It's incredible to think that the same principle can apply to such different tasks. Recognizing a car in a photo and a robot maneuvering through a room. It seems like there's no limit to what BP can be applied to.
You're catching on. And you'd be right, the applications for BP go far beyond what we've discussed so far. You had also sent over research on everything from optimizing manufacturing processes to detecting signals in chaotic systems.
Right. It was almost overwhelming seeing how this one algorithm popped up in so many different fields. But I have to admit, I did start to feel a little lost in the weeds of all the technical details. What I'm really curious about is, what does this all mean for me, for the average person? Why should I care about this algorithm even if I'm not a computer scientist or engineer? That's the million-dollar question, isn't it? We can talk about algorithms and neural networks all day, but what difference does it actually make in our lives?
It's easy to get lost in the technical details, but the impact of backpropagation is all around us. Think about the last time you shopped online. Chances are BP was working behind the scenes, analyzing your purchase history and patterns to make sure your transaction was secure.
Oh, that's right. You mentioned BP's role in e-commerce security earlier. It's like a silent guardian, protecting us from fraudsters.
Exactly. Or think about personalized recommendations you see on streaming services or online stores. Those are powered by algorithms that learn your tastes and preferences over time. And yep, you guessed it. Backpropagation is often the engine behind that learning process.
So it's not just about robots and self-driving cars. It's about making our everyday experiences smoother, safer, and even more enjoyable.
Precisely. And this is just the beginning. As these algorithms continue to evolve, they'll touch more and more aspects of our lives, from healthcare to education to entertainment.
It's exciting and a little bit daunting at the same time, wouldn't you say?
It certainly keeps things interesting. And that's why it's so important to understand the fundamentals of how these technologies work. The more we know, the better equipped we'll be to navigate the changes ahead.
Well said. It's like having a basic understanding of how a car engine works even if you're not a mechanic. It helps you appreciate the ride a little bit more.
Exactly. And who knows, maybe this deep dive will inspire someone listening to become the next great AI innovator.
I love that thought. So to wrap things up, we've explored the intricate workings of backpropagation, its remarkable ability to learn and adapt, and its ever-expanding influence on our world.
From recognizing images to guiding robots to enhancing our online experiences, this one algorithm is shaping the future in ways we're only beginning to grasp.
It's been an incredible journey into the heart of the AI revolution, and we hope you've enjoyed it as much as we have. Remember, listener, the future is full of possibilities, and with a little curiosity and a lot of learning, who knows what we can achieve. Until next time, keep exploring and stay curious.